Good morning to all. Today I am going to talk about Latin square design. Latin square designs differ from a randomized block design. Randomized block design means two-way ANOVA. Completely block design means one-way ANOVA. So randomized complete block designs in that the experimental units are grouped in blocks in two different ways, that is by rows and columns. Therefore, two different sources of variation can be isolated. A restriction in the assignment of treatments in a Latin square is that each treatment can occur once and only once in each row and column, so that each row and each column is like a complete block. A requirement of the Latin square is that the number of treatments, rows, and number of replications, columns must be equal. Therefore, the total number of experimental units must be a perfect square. For example, if there are 4 treatments, there must be 4 replicates or 4 rows and 4 columns. This is a 4 cross 4 Latin square, which gives a total of 16 experimental units. Because of this restriction, Latin square experiments can become large and unmanageable very readily. Also, if the number of treatments is too small, there are too few degrees of freedom for error, so that the most common squares are the range of 5 cross 5 to 8 cross 8. Normally, 2 cross 2 Latin square design is not a Latin square design. So 2 cross 2 is not a Latin square design, but 3 cross 3, 4 cross 4, 5 cross 5, 6 cross 6, etc. are the Latin square designs. So the minimum, so two small values are not a Latin square design. Since two sources of variation are isolated in rows and columns, the mean square for error will be smaller than for the same data analyzed as either a completely randomized or randomized complete block design. However, the degrees of freedom for error will also be smaller as shown in the analysis of variance table. The advantages of Latin square designs are controlled more variation than completely randomized block design or randomized completely block designs because of two-way stratification, results in a smaller mean square for error. Simple analysis of data and analysis is simple even with missing plots. And the disadvantages are number of treatments is limited to the number of replicates, which seldom exceeds 10. If you have less than 5 treatments, the degrees of freedom for controlling random variation is relatively large and the degrees of freedom for the error is very high. That's the disadvantages. And one problem, one example, analyze the following results of a Latin square experiments: A of 12, D 20, C 16, B 10, D 18, A 14, B 11, C 14, B 12, C 15, D 19, A 13, C 16, B 11, A 15, D 20. The letter A, B, C, D denotes the treatments and the figures in brackets denote the observations. So this kind of problems is only solved by Latin square design method. So the total number of items in the given data is 16. The number of columns is 4 and the number of row is 4. And we have above here 3 null hypotheses and 3 alternative hypotheses. All the hypotheses are, first the null hypothesis is there is no significant difference between columns, and there is no significant difference between rows, and there is no significant difference between treatments. And the alternative hypothesis H1 is there is significant difference between columns, there is significant difference between rows, and there is significant difference between treatments. So the Lattice square design means row, column, and treatments. So the other name of the Lattice square design is three-way ANOVA. So in your one-way ANOVA means row or column. Two-way ANOVA means row and column, and the Three-way ANOVA lattice design means row, column, and treatments. The three-way ANOVA table is column, row, and treatments. The column is SSC, row is SSR, and treatment is SST. And the degrees of freedom is in column, row, and treatment all are n minus 1, n minus 1, n minus 1. And the total degrees of freedom is n minus 1 into n minus 2. And the mean square is MSC, that is the column mean square is SSC by n minus 1, row mean square is SSR by n minus 1, and error mean treatment SST is SST by n minus 1, the treatment mean square is, and the error mean square is SSE by n minus 1 into n minus 2. And the F ratio is the combined of error with column or error with row or error with treatment. If the greater variance is the numerator and the smaller variance is the denominator. So in this problem, we have to calculate first of all T means sum of all the items. So in this problem, we have 4 columns and 4 rows and also 4 treatments. So first of all, to consider all the values. So take the values of that means in this problem to consider A, B, C, D or x1, x2, x3, x4. That is x1 or A is 12, 18, 12, 16. x2 20, 14, 15, 11. x3 16, 11, 19, 15 and x4 10, 14, 13, 20. First of all, you consider to calculate summation of x1, summation of x2, summation of x3 and summation of x4. That is T. Step 2, find the correction factor is T square by n. That's a total sum of square. T square, the sum of all the items square, the squares of sum of all the items by all the values of a problem, number of values of a problem. Third, find total sum of square, TSS. So squares of all the items minus the correction factor. Next, column sum of square. Column sum of square means summation of x1 the whole square by n1 plus summation of x2 the whole square by n2 plus summation of x3 the whole square by n3 plus summation of x4 the whole power square by n4 minus CF. Then we get the value is 2.5. Second, row sum of square SSR is also summation of y1 the whole square by n1 plus summation of or m1. So n and m are both are different. In this problem, in the lattice square is a square. Lattice square is a perfect square value. So both number of columns and number of rows are same. So no, so n or m or l. So the differentiate is not needed. So summation of y1 the whole square by m1 plus summation of y2 the whole square by m2 plus summation of y3 the whole square by m3 plus summation of y4 the whole square by m4 minus CF. Then we get the answer is 3.5. And the treatment. To find the treatment, first of all to rearrange the given problem. So rearrange means to arrange the A as a first column, B as a second column, C as a third column and D as a fourth column. Then you have to find the SST is summation of A the whole square by L1 plus summation of B the whole square by L2 plus summation C the whole square by L3 plus summation D the whole square by L4 minus CF. Then we get the value is 144.5. And the error sum of square is total sum of square minus column sum of square minus row sum of square minus treatment sum of square. Then we get the value is 6.5. And also find the degrees of freedom for column is n minus 1, row is n minus 1, and the treatment is n minus 1. That is the here's a perfect square matrix, so 4 cross 4 matrix, so 4 minus 1 equal to 3. And the error degrees of freedom is n minus 1 into n minus 2, so 4 minus 1 into 4 minus 2, the value is 6. And to find the mean square, so MSC is equal to SSC by n minus 1, so 2.5 by 3 is equal to 0.87, and MSR row mean square is SSR by n minus 1 is the value 3.5 by 3 is 1.167, and treatment mean square is SST by n minus 1 is the value 144.5 by 3 is 48.17, and the error mean square is SSC by n minus 1 to n minus 2 is 6.5 by 6 is 1.08. And to find the F ratio means to calculate error with column first. So here the error value is 1.08 and the column value is 0.87. So error value is greater. So 1.08 by 0.87 is value 1.24. And the second F ratio with R. So error with R equal to here 1.08 is the error and the 1.167 is the row. So row is the numerator and the error is the denominator. So 1.081. And also the treatment mean square treatment mean square is greater than the error mean square. So the value is 44.60. Next table value in the first the F test with the column, the error is the numerator. So the table value is 6,3. The table value 6,3 is 8.94. So the calculator value is 1.24 and the table value is 8.94. So here table value is greater, so accept H naught. Second, F test with the row, the calculator value is 1.081 and the table value is 3,6. So it's a 4.76. Here also table value is greater, so accept H naught. And the treatment F test with the treatment is the calculator value is 44.60 and the table value is 4.76. So here the calculator value is greater, so reject H naught. Thank you.